Right, let's start the discussion of term test paper number 2, MCQ paper, right? Question number 1, kilowatt hour is the unit of. Kilowatt hour is the unit of. Just simplify this one. Kilowatt hour, kilo 10 to the power 3, what is joule per second? Hour converted to second, 3600 seconds, right? Then second is to per second, cancel. It comes 3.6 into 10 to the power 6 joules, right? Then kilowatt hour is same as the measurement coming from joule. Joule is energy. Answer is fourth one, right? Question number 2. Which of the above quantities having no dimensions? No dimension. First, the plane angle consists in the SI unit of radian, but it doesn't have dimension. No dimension for plane angle, right? Plane angle doesn't have the dimension. Next, charge. This could be charge. Charge does have the dimension. Voltage does have the dimension. And current does have the dimension. They are having unit as well, the dimensions, right? Okay. Then answer should be second one. No dimension one is only second answer, right? Okay. Okay, question number 3. You are asked to find the reading of the spirometer, but spirometer goes down. The plate of the spirometer moved towards downward. Then you should take the reading. Then main scale, it is covering 1, 2, 2 covers. Then 2 millimeter plus. And next one, here we have 14. Then this one 39, 38, 37. 37 is the direct reading. But today it is going down by the reversible count number. That means backward counting number from 100 division, right? Then it should be 100 minus 37 multiplied by least count is 1 divided by 100 millimeter, no? By subjecting these two, yes, 0.01. 0.01 millimeter. So answer is 2.37 minus from 100, 63 millimeters. Then correct answer is second one. Okay. Question number 4. Least count of measuring instrument depends on least count. Basically, least count is written least count of the main scale divided by number of divisions on the subscale. On the subscale, basic equation is this one, right? Then according to that, the measurement is not depending, is wrong. Least count of the main scale does depend, be correct, including in the answer. They need the correct one. Number of divisions per unit length of the subscale. Harine. Number of divisions per unit length. Divisions can vary when these count right. BC correct, right? Then correct answer is B and C correct. Second answer is the correct one. Okay, right. Okay, question number 5. Which of the following is not fundamental unit? Units, right? Ampere unit, CD candela unit, K capital Kelvin unit, but M is not the unit, right? M is prefix one, multiple value. That means mega. It's 10 to the power 6, no? 10 to the power 6 from the given factor. Right, mega. That is wrong, right? Then that is not fundamental unit. Correct answer is fourth one. Okay, number 6. The percentage error of a certain length has to be below 2%. Percentage error should be maintained 2%. Percentage error is basically written least count divided by reading. Reading multiple by 100. Right. Then simplification makes reading is 100 divided by 2. It's 50 millimeter, which means 5 centimeter, right? That's fair. Then answer is this one. Then the length has to be greater from 5 centimeters, right? Answer is fourth one. Okay. Question number 7. Which of the following quantities consist of vector and a scalar respectively? First should be the vector. Wrong. Here first one is scalar and second one also scalar. Wrong. Momentum and distance correct as well. Force and potential energy correct. Then we have 2 answers, third and fourth answers. Okay, then next one, number 5. Both are vectors, then first one is not the vector. Okay, question number 8. Consider following statement made about zero error of an instrument. A, the error occurring of the measurement due to the instrument is systematic error. Yes, systematic error. A correct. B, the effect of zeroth error can be reduced by taking few readings. Wrong. When you take few readings, whether obtaining the reading, if it is having some errors, we can remove that error. Reading error can be removed by taking several readings, or uniformity can be avoided like that. C, when the magnitude of zeroth error is less than that the least count of the instrument. Yes, least count ekata wada neda. Zeroth error value less than, it won't be measured, no? Yes, then that is also not measurable one. Then hard to obtain. Yes, this is correct, this is correct, this one is wrong. Then this one is wrong, this is correct. No, A correct, C correct. Correct answer is third one. Okay. Question number 9. Two particles A and B travel in two parallel paths towards the direction of starting from the same path. Yes. Point at which their velocities becomes equal. Displacement time graph, right? So they equal velocities. Then velocity is the gradient of the graph. Velocity is the gradient of the graph as displacement time graph. Then can you identify this one having the constant gradient, no? B part is having constant gradient. With that gradient, if you can identify any point having the parallel arrangement, any point having the parallel arrangement, where do we have? Pute, according to this shape, we can identify at a point this slope. And the slope in the adu ene එකක් නේ තියෙන්නේ. බලන්න එක හරි නේද කියලා. According to this shape, the shape එක මෙහෙම යන එකක් තියෙන්නේ. at a point, this one and this one will be parallel. It will be done in the first 10 seconds. Okay. As well, we can identify here increasing gradient. Put the increasing gradient from 0, no? The initial slope is 0. And then slope increases. At a point, this line and the line of B will be parallel to each other. Again, tanak ena hotana hari. Instantaneously, they will have parallel with each other. So the correct entertainment we can identify 20 to 25 as well, 0 to 10 seconds. Then can you identify the correct answer is 3? Yes. Okay, Buddha. Question number 10, basic simplification. Is it like this? The periodic time of soap bubble you are given depend upon under the simple harmonic motion P pressure ml minus 1 t minus 2 to the power of x, and d is the density ml minus 3 that of y, and last thing is as surface tension. Dimension of surface tension same as spring constant, right? Spring constant mt minus 2 to the power of z. Now you have to say here m base is having 0, here x having, and y and z available. Next one. Here L base is not having. L is having here minus x plus minus 3y, done. And T base here consisting 1 equal. T has minus 2x plus minus 2z, done. Then we can take the combination by simplifying these two. Combination in between y, z can be easily identified. Take this one into this side, right? And then x including with y, and then relationship of x and y can be identified as this one is 1. Then take that substitution with this one. Then answer becomes, okay, you can say this one ABC, no matter. A is 3 by 2. Here x is 3 by 2 minus y is half and z is just 1, right? Okay, take the final answer. You should simplify, right? Number 11. Okay. Number 11. Figure shows the path of AB of a ball projected from the point A. Neglect air resistance. Consider the following statement. A, velocity of the ball at the maximum height of the path is 0, rho. In a projectile motion at the maximum height, right? Velocity vector directed into this side, that is equal to u cos theta, right? If the initial velocity is u at an angle theta, this could be the horizontal velocity component. It is remain unchanged at the maximum height. B, A is wrong. The velocity of the ball at the point B is equal to velocity at A, velocity of A and velocity of B. They equal in magnitude, but direction changes. While it is projecting upward, velocity directed up. When it is coming down, velocity vector directed downward. then you can see initial velocity and final velocity both are lied with the same magnitude, agreed with the magnitude, but direction opposite. No? But velocity is a vector quantity. When you consider equal magnitude of a velocity, direction should also be the same one to complete the correct statement. Therefore, B is wrong as the direction has changed. C. B වරදින්න හේතුව පැහැදිලි. පටන් ගන්න තැනදී velocity තියෙන්නේ උඩට, වැටෙන තැනදී තියෙන්නේ පල්ලෙහාට. C. Kinetic energy of the ball at the point B is equal to kinetic energy at the point A. Kinetic energy, it should be written by using half mv squared. V will be squared, no? Even though velocity is a scalar one or vector one, anywhere, no matter. Squared value becomes completely losing the vector properties. Completely losing the vector properties. Therefore, that won't be the vector process. Then kinetic energy exactly scalar one. At the beginning and final, if there is no air resistance, kinetic energies should be same. Then we can say only C is correct answer. Second one is the correct one. Okay, right. Number 12. Figure shows the displacement time graph of two objects starting P and Q moving along a straight line. Consider the following statement. Puta, you can see P consisting increasing gradient of ST graph. Then this one shows the acceleration. And this one shows decreasing slope, decreasing gradient. Decreasing gradient is decreasing velocity, it consisting deceleration. Then Q is having deceleration, A is having acceleration. Okay, first statement is correct. Both objects have velocities in the same direction as they are having increasing velocity. Going up, no? Therefore, statement A is correct. B, velocities of both the objects increases with the time. Increases with the time. That's wrong. One is increasing, the other one is decreasing. C, both objects have the same velocities at crossing point of the graph. When you consider this, that point, they are having two different gradient at that location. Gradient of the graph gives the direction of gradient of the graph gives the velocity. Gradient, two gradients. One is having high gradient, the other one is having low gradient. Can you see that? Yes. Then when they are meeting and then crossing with each other, they are having same displacement. That's all. In displacement time graph, they will have same distance, right, Pude? Okay, done. That could be the correct procedure. Number 13. Question number 13. Okay. A ball is projected upward at an angle 60, like this. Ball is projected upward at an angle, yes, 60 degree. Then direction of projection, if it is like this with the velocity u at an angle here 60 degree, and the kinetic energy of the initial projection is A, K, then K is written half m u squared, like this one, first one. Okay, and then at the maximum height, you should know velocity is u cos 60. u cos 60 half, it becomes u by 2. Done. Then kinetic energy, let it k dash, it could be written half m u is u by 2 at the maximum height. They are thinking at the maximum height, velocity is 0. That's what, right? Therefore, you can divide each. Then k over k dash becomes half m, u squared cancel, 2 squared coming up, it becomes 4 here. Then k dash becomes k by 4, like that. Then correct answer is third one, isn't it? Done. We need basic theory, right? Right, question number 14. Number 14. Consider following statement made about motion of an object, right? Motion. Velocity of a particle cannot be reversed. They need incorrect statement. It is bolted here. Incorrect one needed, right? Velocity of a particle can be reversed without changing the direction of acceleration. Is it like this? Without changing the direction of acceleration. Example, when you throw an object from the ground towards upward with a certain velocity, right? We all know it is going up until that velocity becomes 0. After reaches to here, it turns down and then finally completing the motion after hitting on the same point. Then පුතාලට පේනවද? Upward direction completely changes, but gravitational acceleration of 10 ms minus 1 remains same throughout the entire motion, even though it is moving upward or downward. Any way of direction, upward or downward, no matter. Gravitational acceleration take place only one direction, towards downward. Then, without changing the direction of gravitational acceleration, we can change the direction of motion. And velocity of the particle can be reversed without changing the direction. Statement is correct. That won't be set in the correct answer, right? But they need incorrect one. Statement is correct, but it won't be included in the final answer. B. When the particle is projected up with a large initial velocity, කොච්චර ලොකු velocity එකකින් යවුවත් the gravitational acceleration won't be exceeded. එහෙම කරන්න නම් engine එකක් high කරලා fuel burn කරලා උඩට විදින්න ඕන. නිකම් project කරාට වැඩක් වෙන්නේ නැහැ. Always having the gravitational acceleration. Large velocity, the deceleration will be exceeded the gravitational acceleration value. Right? It won't be exceeded. Deceleration, කවදාවත් 10ට වඩා වැඩි කරන්න බෑ. Correct? When the particle is at rest at the given instance, it may have an acceleration. If the particle is rest at a given instant, make an example. If the particle remain at rest at the given instant, right, not the time period, at a given instance, yes, done, but there is a gravitational acceleration. It is possible, no? Today, if you are given a certain statement, if you can identify just a point, right, availability of the statement, that statement is correct, right? When the particle is at a given instant, it may have an acceleration. තිබිය හැකි. පුළුවන් නැති වෙන්න පුළුවන්. සමහර විට object එකක් දිගටම නතර වෙලා තියෙනවා වෙන්නත් පුළුවන්. Without moving. එහෙනම් at a given instance velocity 0, another velocity 0, another instance velocity 0 වෙන්න පුළුවන්. හරි. දැන් කියනවානේ it may have an acceleration. Yes, possible. Right? While having the resting location, but there is a gravitational acceleration. මං හිතනවා පැහැදිලි කියලා. Then statement Z correct, then wrong one is B. කියන්නේ අපෙන් අහන්නේ incorrect එක නම් correct answer should be B, no? Yes, done. Okay. Number 14 complete. Can you check the others? Right. You are given a child of mass 20 kilograms standing on a manual elevator by hanging a rope that is moving around two pulleys without the friction and mass. The pulleys වලට masses නැහැනේ. Can we label the forces, Puta? Right on here. 20 kilogram. And the elevator is also 20 kilogram. Then this person is having 20 kilogram, 200 Newton. Okay. And the elevator base is also having 200 kilogram. Sorry, 20 kilogram. Then total weight is 400. Okay. Then is it like this? This one is having 200 Newton. Here plate is also having, stage is also having 200 Newton. Okay, then what do you call? They need the force exerted by the rope on the man. Force exerted by the rope. Force exerted by the rope on the man. Rope එකෙන් මනුස්සයට දෙන force එක. ඔය කියන්නේ මනුස්සයා rope එකට දෙන force එකේ අනිත් පැත්තනේ. Now you are asked to find this tension. මම එක මාක් වුණාද කියලා හරියටම වාගේ ඇති. ඒකේ අනිත් පැත්ත අහලා තියෙන්නේ. ඒ කියන්නේ force acting on the man by the rope. ඒක අහලා තියෙන්නේ අනිත් පැත්තෙන්. ඉතින් හරියනේ force acting on the man by the rope is same as force exerted on the rope by the man. Action reaction pair. එහෙනම් මම මේ T හොයනවා. This one is T. This is also T. Right? Here same tension as the same string, and here also T. Put a light pulley, then TT. This could be 2T. Total weight should be equal to total upward forces. This one is also 2T as the same string. Here we have 2T, and here we have 2T another. Okay, then can we consider this portion together? What? Equilibrium of this whole one is considered. Then we can see upward we have 2T, and upward we have T from here, and upward we have another T. මේ රතු පාටින් ලකුණු කරපු පැච් එක ඇතුලේ තියෙන forces ටික විතරක් ගන්නවා. Equals to 400 Newton. Then 4T equal 400. Then T becomes 100 Newton. T is 100 Newton. Then they need force, no? It should be first answer. Force එකක් නේ පුතේ අහලා තියෙන්නේ. The force is measured in Newton, right? In SI unit QR, මේකනේ මේ උත්තරේ. This is wrong, right? Not 10 kilogram. Answer should be 100 Newton. Okay. Can we check number 16? 16th question. Two spring balances of X and Y two spring balances of X and Y. The upper one is having the hook at the lower position here. Here, lower one consists in the hook at the upper position. And the hook tension of the hook is the reading of the spring balance. Then they are seriously connected. As the figure, the reading of each spring balance respectively, if 10 kilogram is suspended. If 10 kilogram is suspended. Can you label the forces? First thing, here we have 100 Newton. Here we have the weight, it is mentioned, the spring of Y is 2 kilogram. Yes, Y is 2 kilogram. This is having 20 Newton. Then put it, this hook is having the tension 120 Newton, which means 12 kilogram. Done. This is the reading of, or this is the tension of the upper hook, right, of the lower spring. Then reading should be 20 kilogram. Reading is 12 kilogram. And additional to that, here, tension is created here. But මෙයාගේ weight එක අදාළ වෙන්නේ නැහැ. එතකොට 30 kilogram, 30 Newton is not experienced by that spring's own reading. Then X including this tension, and that is same as this one. Then you should be labeled the correct answer, fifth one. මාන්න පුතාලා වැඩේ හරියට ගත්තා නේද කියලා. Fifth answer is the correct answer. Okay. Clear. Can you check next one? Okay. Question number 70. Okay. Number 17, you should think like this, Pute, right? Each block shifted, no? One by one, blocks are shifted. Pute, here we have to manage the position of center of gravity like this. Center of gravity of upper one is right here. Center of gravity of upper one right here. This one right here. This one right here. This one right here. The make a පහළ තියෙන එක්කෙනා එයාව අතෑරියාම අට පේනවද මේ තුන් දෙනාගේ center of gravity upper this and this center of gravity is right here, no? Center of gravity of other three masses should be laid at the midpoint line joining them as they are having equal distances, right? Identical blocks no එතකොට මෙයාගේ center මෙයාගේ තුන් දෙනාගේම center of gravity method එක. පුතා අන්න එතනින් ලකුණු කරන්න ඒගොල්ලන්ගේ weight එක. පුතේ මෙන්න මේ weight එක හරිද මේ edge එකකින් එළියට පැනනවා. බැරි වෙලාවත් ඒ weight එක මම එක වෙන පාටකින් ගන්නවා. If you consider මෙයාගේ center of gravity of the other three, right? Having like this, or පේනවද මෙන්න මෙතනින් එනවා topple එකක් මේ. This center of gravity මේ රතු පාටින් ලකුණු කරපු එක නම්, right, is the center of gravity. It will have a topple to falling down the whole system towards clockwise. එතකොට අර normal reaction එක කියන එක ඉන්නේ මෙතනින් නේ. Finally, through the center of gravity, right, if the center of gravity lied at this side, this is making the moment into this side, right? Normal reaction always lied along the maximum thing is edge. When I edge again, the normal reaction it is made regaining moment of force. Here, falling moment of force are making regain moment of force. Then what the logic again? And I make a maximum theorem. Center of gravity should be lied along the edge. එතකොට පුතේ අර උඩ තියෙන තුන් දෙනාගේ weight එකයි ඒ කට්ටියකින් හදන normal reaction එක line වෙලා equilibrium එකේ තියෙනවා. maximum equilibrium occurred. අන්න කතාව පැහැදිලිද කියලා. Yes. එහෙමනම් අපි logic එකක් හදනවා කොහොමද? When these three, this and this, right? Placing like this, right? This should be the arrangement. Then one by one should be shifted, right? එහෙනම් පුතාලා තර්කයක් ගේනවා මෙතන ඉඳලා මෙතෙන්ට දුර L/2. Here to here L/2. පැහැදිලිද බලන්න. එහෙනම් මේ centers shift වෙලා තියෙනවා මෙතනින් x x x. එහෙනම් මෙතන ඉඳලා මෙතෙන්ට 3x වෙන්න ඕනේ. පැහැදිලිද බලන්න. That is 3x, yes. Then 3x equals L/2. Then x becomes L/6. Done. Correct answer is L/6. Can you note down this one? Correct answer is L/6. Number 18. Okay, taking number 18. Figure shows the motion of an object. Figure shows the motion of an object under the straight line. Consider the following statement. The direction of acceleration of the particle is changed during the motion. When do you know the this one shows the positive direction here. Positive direction. This one shows negative direction. Make a hurried nikam me wagi motion ekak puthe me bala. Here we have ground level. This one shows like this, an object coming down until hitting on the ground. After obtaining the velocity of 2v, it is obtained. When it is obtained, when it reaches to the bottom, it will obtain the velocity of 2v, right? And after that, collided with the ground, it goes with the velocity of v0, which means velocity drop down. Due to the kinetic energy loss, velocity drop down, then it won't be travel to the same height like this. Definitely at this moment, after reaches to here, direction has been changed. Then statement A, the direction of the acceleration of the particle is changed during the motion. No, it's wrong. Direction of acceleration remain unchanged. I'll give an example. While having the acceleration downward, but it goes back with the gravitational deceleration, but gravitational acceleration lie towards downward. පුතේ මේ වගේ ප්‍රශ්නයක මේ motion එක තමයි මේ ඇඳලා තියෙන්නේ කියලා ඔයාට හිතුන්නේ නැත්නම් මේක කරන්න බෑ. වරදිනවා. ඔයා කල්පනා කරනවා this one acceleration, this one deceleration, definitely they are having different arrangement. පුතාලට පේනවද මේ? This one parallel to this one. Both the lines are parallel, then same acceleration resulted. Bande එහෙම එකක් වාට හිතුණාද කියලා? Yes, but this one representing the deceleration, but opposite to the gravitational acceleration. Anyhow, acceleration won't be changed. පැහැදිලි? Example, gravitational motion. B. The particle is not returned to its initial position. Correct. Area of this portion and this portion won't be equal. Then statement correct. See, the impulse acting on the particle is infinity. Put the impulse is this one, right? Impulse is called F equal mv minus mu over t is the impulsive force. This is impulsive force, right? Impulse is this one, change of momentum, right? Change of momentum, mass m, velocity 2v. If it is downward, maximum minus v0, put it is upward. Now you can see what direction changes. Then twice of mv0 minus mv0. mv0. Okay, then answer is, they need the correct one, no? A statement is wrong. As direction, you are given direction of acceleration changed, wrong. It is not changed. B, particle is not returned to initial position, correct. C, the impulse is infinity. මේක impulsive force infinity කිව්වා නම් හරිනේ. මෙතන අතර time slot එකක් නෑ. ඒතර t බිඳුවයි. Impulsive force is infinity එක හරි. Why? The time is 0, then impulsive force infinite large. That's correct. But impulse is having here මේක direction මාරු කරපුවාම මෙතන plus වෙනවා. ඒතර පුතේ 3 mv not කියලා. පැහැදිලි? Right. 18 completed. Take number 19 and onward. Right. Number 19. Two masses of 20 kilogram and 10 kilogram are connected by using string of mass 2 kilogram as the figure. The tension of the string at the end of A of the masses are A if the masses are released under gravity. Underline under gravity. Then tension at here needed. No? ඉතින් පුතේ ඔයාට හරි ලේසියෙන් පුළුවන් මෙයාට විතරක් F equal m එදා. දාන්න දෙයක්වත් නැහැ ළමයිට අග්ගාලා කරනවා මේකට උත්තරේ කියයි කියලා. බිඳුව කියලා අපිට හද. This one is the mass. It has own weight. What do you call that? 20. Weight is 10, right? Ten kilogram. It's 100 Newton. Tension is T. Gravitational acceleration 10. ms minus 1. Then step line. F equal ma towards downward, right? F is downward 100 minus T equal mass 10, acceleration 10. T becomes 0. Oops. T is 0. Done. Fifth answer is the correct one, right? Okay. Number 20. Consider following statement made regarding action and reaction pair. A, both action and reaction should be set in two or more objects. Two hari more varadi buddha. It should be two objects. Action and reaction pair should be located on each other. දැන් මම මොකක් හරි එකකට පහරක් ගැහුවොත් එයා සහ මම අතර විතරයි action reaction pair couple වෙන්න ඕන. පැහැදිලි? Statement wise A is wrong. B, they are opposite in direction and equal in magnitude. හරි. දැන් මේ වගේ when we have two objects, this one pushes this one pushes this one, equal in magnitude and direction opposite. Next one, they should be set close to each other. Oh, action එක ළඟම reaction එක තියෙනවා. action එක මෙහි reaction එක ගව් ගානක් ඇත එහෙම තියෙන්න බෑ. දැන් අපි උදව් නිකන් මෙහෙම කිව්වොත් ඕගොල්ලන්ට here we have an object, string is right here, a force is applied on here. දැන් මෙතන force එකක් දුන්නාම මෙතන tension එකක් කියනවනේ. ඒක මෙයාගේ reaction නෙමෙයි. නෑ. මේකේ මෙයා action reaction pair මේ විදියට පුතේ couple වෙන්නේ. And here we have a force T, reaction force is T. පුතේ කවදාව මෙයයි මොකක්ද? එහෙම නැත්නම් මෙයයි action reaction කරන්න බෑ. බෑ එහෙම ගන්න බෑ. හොඳයි. Action reaction pair should be these two as well these two. කවදාවත් ඔයාලට මෙයා action reaction කරන්නත් බෑ. Action reaction won't be created on the same object. It should be lied on two objects, right? දැන් මේ දෙක ගන්න මේ string එකේ තියෙන දෙන්න ගන්න බෑ මෙහෙම මේ දෙක වට කවදාවත් මෙතෙන්ට couple කරන්න බෑ. පැහැදිලිද බලන්න. හරි නේද කතාව? right. එහෙනම් අපි ඒකේ අයින් කරනවා should be set to each other, closer to each other. Yes, done. එහෙනම් එතන පුතාලගේ අතින් C හරියනවා, I ට අමතරව B හරියනවා. මේ වැඩේ තියෙන්නේ මේ කට්ටිය අහලා තියෙන incorrect එක ඒකනේ වැඩි. නේ? Third answer is the incorrect one. Only A is incorrect one. එහෙනම් විස්තර උත්තරේ තුනද බලන්න ඔයගත්තේ. Number 21. Okay. Second young ඉස්සරහට බලන්න. 21 also statement one, no? Consider the following statement made about motion of an object. Let's see again. If ST graph of a motion of an object is a straight line parallel to the time axis, is it like this? Here, ST graph parallel to the time axis. Definitely, it could be at rest, no? The velocity of the object is zero, thus the speed is the rate of change of displacement. Is the statement correct? Okay. If ST graph of the motion, okay, of an object, right, is a straight line parallel to the time axis, the velocity of the object is zero. Yes, correct. Is zero, right? Because the speed is rate of change of displacement. Speed is not the rate of change of displacement. The speed is rate of change of distance. මුල හරි අග ටිකත් හරියටම හරි අර කැත වචනයක් දාලා තියෙනවා. මොකද instead of velocity you are given speed. සුනේ ඒ statement is wrong. එන අහන්නේ correct එකනේ. එතකොට ඒ අයින් වෙනවා උත්තර. A is wrong. එතකොට check කරන්න දෙයක් නැහැ. එක වැරදි පහ වැරදි. ඊටු ටික ටක් ගාලා බල. B. An object can have constant speed, okay, but variable velocity. As velocity is a scalar quantity. Velocity scale එකක් නෙමෙයි මොකක්ද? Velocity is a vector quantity නේ. Velocity is not the scalar quantity. So B වැරදි. A and B both wrong. එනම් බොහෝ විට උත්තරේ නේද? හතර වෙන්න ඇති. check කරන්න බලන්න. When an object is subjected to a uniform velocity, it always moves in a straight line as the displacement is a vector quantity. See, Harine, right. Number 22. 22nd one. Two particles start from rest from the same place. We got me. Two particles like this, starting from same place. They are traveling right here. Okay. With an initial velocity 4ms minus 1. 4ms minus 1 and 2ms minus 1. And the acceleration of 1, acceleration of 2. If both reach the final position in same line, දෙන්නම එකම වෙලාවේදී ඔය කියන හැටියට එකම location එකට එනවා නම් the both reach the final position in the same time, then the length of the path traveled by is පුතාලගෙන් අහන්නේ මෙන්න මේ displacement එක කීයද කියලා. එහෙනම් ඔයාලට එකපාර මෙහෙම කරා කියන්නේ considering s equal ut plus half at square. or make a ලියනවා s both displacement same or ලියනවා 4 into t time 4t plus half into acceleration 1t squared equal just 2t plus half into acceleration 2t squared. Yes, then simplification. We can say 1t cancel, right? Here 2 cancel. Okay, then we have here 4 plus t by 2 equate 2 plus just t, right? This is taken into the other side. It's t minus t by 2, t by 2. 4 minus 2. Metana t becomes 4 seconds, right? Then can we pick this value instead of this one? First thing, we have s 4t. T is 4 plus t squared, 4 squared by 2. 4 16යි 16 භාගය 8යි 16 8යි 24ක්ද බාරන පුතාලට එන්නේ meters. Okay. Question number 22. Correct answer is second one. Right. Number 23. Figure shows displacement time graph of two particles moving along the x-axis. This one shows, it's simple thing. This one shows increasing velocity, which is called acceleration. This one shows deceleration, right? Decreasing velocity as the slope is decreased. First one acceleration, second one deceleration. What do you say? පුතාලගෙන් අහනවා මොකක්ද මේකේ හරි එක කියලා. Right. ඉතින් ඒක statement ටික බලද්දිම පේනව නේද බලන්න. Particle 1 is having acceleration and particle 2 is having retardation. Retardation is deceleration. Fifth answer is the correct. Okay. Number 23, clear. Okay. Can we check the others? Okay, number 24. 24th one. An object starts the motion with an initial velocity and masses with an increasing acceleration. Motion starts with an initial velocity, right? With an initial, ඒක කියපු ගමන් ඔයාට මෙයාව අයින් කරන්න පුළුවන්. This won't be the correct answer. Starting from zero velocity. And increasing acceleration. This is deceleration. Here, this is decreasing acceleration, but acceleration decreases here. Increasing acceleration. But this is also velocity drop down. Increasing deceleration here. This is deceleration. This is deceleration. Here we have negative direction acceleration. Done. Fifth answer is the correct. Done. Right. Number 25. විසිපහ question එකට අපි එන්න උනොත් බලන්න. පුතාලට දීලා තියෙනවා two readings, no? What is the correct diameter of the metal sphere? And basic thing, you should find the least count. Pitch is 0.5 millimeter and 50 divisions available, no? Can we check it? First thing, least count is, here we have 0.5 divided by its 50 divisions, right? 0.01 millimeter is the least count. So the reading on here gives the zeroth error, no? Zeroth error මේක බිඳුවට උඩින් තියෙන්නේ මේ 0 වලට උඩින් තියෙනවා 1 2 3යි Zeroth error is 0.03 millimeter, right? And here reading 3.5 completed, it's 3.5 millimeter plus here 31 plus 31 divisions available to coincide. Here we have 3.5 millimeters scale. Then here positive zeroth error. Positive zeroth error subtraction to be considered, no? 3.81 minus 0.03 millimeter should be considered. Then it becomes 3.78 millimeters. Done. Then correct answer. The මේ වගේ වරද්දන්න එපා පුතේ මේක. මහලොකු දෙයක් නෑ. Just identifying the zeroth error, just taking the reading and considering the final result. There මතක තියෙන්න ඕනේ positive zeroth error correction is negative. Yes. Number 26. Okay. What do you say? The speed of the projectile at the maximum height is half of its initial speed u. Its horizontal range is the speed of the projectile. Is it like this? The projectile motion is shown right here. Done. Initial velocity, let it u, is half of the initial velocity at the maximum height. This velocity, half of this angle, let it theta, u cos theta, according to the question, you are given u by 2, half of the initial velocity. You cancel, then you can say cos theta is half, theta becomes 60 degrees. First thing is this thing, right? Angle is 60 degrees. පැහැදිලිද බලන්න පුතාලට? අහනවා මොකද්ද? The horizontal range. මෙතන ඉඳලා මෙතෙන්ට තියෙන දුර අහනවා පුතාලගෙන් කීයද කියලා. ඉතින් ඒකට ඔයාලට ඉක්වේෂන් එක ලියන්න පුළුවන් නේද? u squared over g sin 2 theta. මේක මතක නම් එකපාර ලියන්න. නැත්තම් derive කරලා ගන්න. ඉතින් finding the time of flight and finding the horizontal range. What a nice, no? U squared over g sin 60 angle, 60 into 2, right? It's sin 120, no? Sin 120 is sin 60. Sin 60 equal sin 60 root 3 over 2, right? Can we pick the correct answer? Third answer is the correct one. Third answer is the correct answer. Okay. Right. Let's see question number 27, right? Okay. Number 27. මොනවද කියන්නේ? The block of mass 200 kilogram rests on the block of B of mass 300 kilogram. Is it like this? Top mass is having, මේක isolate කරලා ගමුද? Okay. The weight of this one is 2000, right? Newton. Weight of this one is 3000 Newton. Coefficient of friction between A and B is 0.25. දරුවනේ, when you are trying to drag lower object towards right side. This is sliding over this surface. Then tension will be created right here. Then frictional force belongs to the upper mass, F1, directed backward to the tension, right? පුතේ එයාගෙන්ම මෙයාට submit වෙනවා the corresponding force created on B by A equal in magnitude to the friction backward. As well, this is drifted into this side will have frictional force of F2. පුතේ මෙතන frictions දෙකක් කියනවා. කොහොමද? When you apply a force towards right side, this is dragging. මෙයා drag කරද්දි මෙයාගේ tension එකක් මේ tension will be building up to stop the motion as the string. Then frictional force will be backward. Done? Okay, then can we find F1? Finding F1. F1 equals mu r 0.25 multiplied by normal reaction right here, just 2000 Newton. 2000 Newton. Then F1 equals, it's 500 Newton, right? And the next friction, F2 equals mu. We have B and flow is 0.2. Normal reaction, total normal reaction is 2000 plus 3000. It could be 5000 Newton. Then we have here 5000. Done. It could be 1000 Newton. Then the overall backward force is 1500 Newton. What do you call? What's the question? The horizontal force F needed to move the block B. Make a yantam mehata adino kiyala kiyanne this one should be equal to sum of this one. Then F could be 1500 Newton. Done. Is that clear, Buddha? Right. Then correct answer is third one. Done. Okay. Can you check question number 28? පුතාලට ලියා ගන්න දෙයක් තිබ්බොත් රෙකෝඩින් එක නවත්තලා අවශ්‍ය දේවල් ටික ලියාගෙන පොඩි ડોකියුමන්ට් එකක් විදියට හදා ගන්න පුතා. Okay. Right. Next one. 28. Can we check? A ball of mass like this. A ball of mass M thrown up with a velocity of u. Okay. If air exert an average resistance force, ekane udata yandi a resistance tin pallehata. Okay. Resistance force F, the velocity with which the ball returns back to the thrower's hand is. Make udata gihilla ay watenna ඕනේ නේ. එයාලා ඉල්ලනවා මෙන්න මේ velocity v1. Okay, air resistance available. Right. Make a lasing hadanda puluwan kramayak tiyena. Without using motion equations. What do you call that? We can use energy, mechanical energy conservation. How? At the beginning, with the projection, we have half mu squared kinetic energy. That kinetic energy will be converted to potential energy, then let this height h plus part of this one converted to this one. The rest of the part will be used to work done against the air resistance. This is initial kinetic energy. This one is obtained potential energy. This one is work done by the air resistance. And at the initial stage, when it is going down, we have mgh, potential energy. Part of that one will be converted to kinetic energy, and the rest of part will be converted to work done by the frictional force. Then subject in this one, half mv1 squared equal mgh minus fh. Let this one first one, this one second one. Can we divide first and second one? How? Half mu squared over half mv squared equal, we call that mgh plus fh over mgh minus fh. Now you can see half m will be cancelled. Done. H, common factor, numerator and denominator cancel. Then you can say what? Here, u squared over v1 square equal mg plus f divided by mg minus f, right? Done. Then they need v1. v1 equal u square root of mg minus f, mg plus f. Done. That's called the answer. Correct answer is third one. Right. Okay. Question number 29. Let's check 29. Okay. Number 29. What's next? A long spring is stretched by 2 centimeter. Its potential energy is U. Here we have spring stretched by 2 centimeter. Like this. 2 centimeters stored energy is U. The spring is stretched by, if the spring is stretched by 10 centimeter. Stretched one right here, 10 centimeter. Here, stretched one, 2 centimeter. Here, 10 centimeter. They need potential energy stored will be, okay. Potential energy E equal half k x squared. How? Initial potential energy is U, half k, then x is 2 centimeter, right? Done. Then what about new elastic potential energy? U dash half k, displacement is 10 centimeters, that of squared. Make a better. U over U dash equal half k cancel. දෙවරක් එකයි පහයි එකයට පහේ ස්ක්වයර් එක කියලා එනවනේ. Then we have U equal, U dash equal 25U. බලන්න හරිද කියලා. Just using this equation. Done. Correct answer is fourth one. Right. Number 30. A light body A and B, A and a heavy body B have equal kinetic energies of translation. Translation means linear, right? Okay. අපි බලමු බලන්න. Number 30. A light body of A, aka mass එක අඩුයි නේ එතකොට, and heavy body of B have equal kinetic energies. Basically, kinetic energy is written E equal half mv squared, right? Additional to that, we are using half into, we can say the rho p squared over m, right? P is momentum. P is momentum. Then kinetic energy of both, according to the question, right? Equal kinetic energy. This is equal for both. Then can we subject P? P squared equal half, sorry, E, P equal 2m goes into this side, 2em, right? Then P momentum is 2em root. Then පුතාලට පේනවද? This one remains same. මම එක constant එකක් කියලා ගන්න. Constant. Then momentum directly proportional to mass. මෙන්න මේකෙන් බැරිද අපිට උත්තරේ ගන්න. Light mass is having low momentum. Heavy mass is having mass එක වැඩි එක්කෙනාගේ. M is low, momentum is low. මෙතන root දෙකක් තියෙනවා. M is large, momentum is large. M is large, momentum is large. එහෙනම් මට උත්තරේ තෝරලා දෙන්න. The light body a light body A has light body, then momentum of A B should have the larger momentum than that of A, no? As equal kinetic energies. Kinetic energy getting equal, then this one goes into this side, then we can say this and this. එනම් බණ්ඩවාගේ හොඳම තේරීම මොකක්ද වෙන්න ඕනේ කියලා. B has larger momentum than A. Best answer is second one, right? Okay, second answer is the best one. Number 30, correct answer is second one. Okay, right. Number 31. A child of swing of 1 meter above the ground at the lowest point and 6 meters from the ground at the highest point. Okay. The horizontal speed of the child at the lowest point of the swing is, this one is the swing, right? The child of a swing is 1 meter above the ground at the lowest point. This is 1 meter. And from here to here, you are given 6 meters above the ground at the highest point. අපි මෙහෙම ගත්තොත් මෙන්න swing එක. Highest point is this one. This is 6 meters. Then Kute, you can see from here to here 5 meters. Thank you. This level is having 0 potential energy level. Then you can see at here we have potential energy mgh. When it turns to here, it obtains half mv squared. How easy? අර ගාන කියවලා ප්‍රොෆයිල් එක ඇඳ ගන්න එක තමයි වැදගත්ම දේ වෙන්නේ. Then you can say mgh equal half mv squared. mm cancel. G twice of g10 h5 equals v squared. U becomes, yes, 10 ms minus 1. Done? Okay. Then answer is second one. Take the correct answer. Next, number 32. The variation of kinetic energy on the object against momentum, no? Equal half m half p squared over m, right? They need the variation of kinetic energy against momentum. Then kinetic energy, we can say half p over m multiplied by p. Then this one is represented y-axis, this one x-axis. This whole thing is the gradient, right? Then gradient is tan theta. Tan theta represented p over 2m. With the distance of this axis, gradient here p increases. Then make a value x-axis p the p value increases. P value increases, then the gradient, what will happen? Gradient increases. As p is increased, gradient here, this value increases with the distance of p. Then answer is second one. Can you note down? Second answer is the correct one. 32. Clear, right? 33. Number 33. Two forces have the magnitude ratio of 3:5 and angle between the direction is 60. Right, number 33. The ratio of magnitudes 3:5. No? 3x 5x. Then magnitudes are, no? They need the magnitudes. That resultant is 35 Newton. Make R squared equal P squared plus Q squared plus 2PQ cos theta, right? If it is used, then simple. Let's see. R 35 squared equal P 3x squared plus 5x squared plus twice of 3x into 5x into cos angle is 60. So take cos 60 half is to 2 cancel. Then here we have 9x squared plus 25x squared plus 3 into 5, 15x squared, clear, and equals to 35, done. Then put a 35 equating 25 මෙතනින් 15යි. ඔයගලන්ට එනවා එතකොට value එකක් එතනින් 25යි 5යි 30යි 40යි 49ක් කියනවා. x squared නේද බලන්න. Right. Then we can continue the simplification. මෙතන ගනිද්දී 35 square එක දාන්න. හරි. 35 squared. Thousand 225 like that, no? Yes. Then put the x squared becomes මෙයා 49න් බෙදන්නනේ. බලන්න එතකොට ඔයාලට 25ක් එනවා. Then x becomes 5. එහෙනම් දැන් ඔයා values දෙක දෙනවා මොකද්ද? 5 වරක් 3 15යි newton and 5 වරක් 5 25යි newton. These two are the answers. Can we pick the correct answer? පොඩි simplification එකක් තියෙනවා. ඒක මහා ලොකු දෙයක් විදිහට හිතන්න නැතුව නිකන් ගත්තා. මේක පුතේ short methods available නේ. 3:5. 3ට 5 ratio එක ගත්තාම මෙතන answers වලින් අපිට අයින් කරන්න පුළුවන් ඒවා තියෙනවා නම් අපිට එහෙමම අයින් කරලා දාන්න පුළුවන්. නමුත් මේකේ ඔක්කොම answers ratio එකට දීලා තියෙන්නේ නේ. Okay. See next question. Number 34. Okay. Right. Number 34. A gymnastic player of mass 50 kilogram stands on the ground vertically with the velocity 6 ms minus 1. With its body straight, as the feet touches the ground, he bends his knees while keeping rest of the body vertical and brings his body to a complete stop, 0.2 seconds. Like this, no? When we have this kind of arrangement, velocity of 6 ms minus 1 after 0.2 seconds later finally comes to 0. Then you can say F equal mv minus mu over t. Hari saralai putene. F, the body of mass 50, finally obtains 0 velocity from the body of mass 6 ms minus 1. Let the initial direction is downward during the time of 20 seconds. Direction has changed. Sorry, time is 0.2 seconds, right? Then force becomes here 300 divided by 0.2, which means 3000 divided by 2, it's 1500 Newton. Third answer is correct answer. Okay. Number 35. A body of mass m, a block of mass m, is kept on the horizontal truck bed like this, no? Here we have truck when it is moving into one direction. This is the position of the object, block of mass m, which is respect to the truck when it is moving with a constant acceleration. ඉතින් මෙයා මෙහාට accelerate වෙද්දි මෙයා ගැස්සෙන්න හදන්නේ පිටිපැස්සටනේ. Then friction offers towards this side, right? Friction offers frontward. Then weight is mg, normal reaction is r. So we can say the coefficient of static friction between the lorry bed and the mass is mu. The frictional force acting on the mass is given by පුතේ මේ F equal mu r දාන්න වෙන්නේ මේ object එක almost slide වෙනවා නම් විතරයි. මේක එහෙම එකක් කියලා නැහැ. In the question, it is not properly mentioned whether the object is obtained limiting equilibrium. It is not mentioned. Therefore, that one is not valid. Just apply F equal ma for the mass. F is the friction, mass is m, acceleration e. Then ma product could be the frictional force. What a mu mg කියලා ගන්න පුළුවනි ගන්න නම් මෙයා ඉන්න ඕනේ limited friction එක. මේක ඇවිල්ලා maximum friction. මෙයා maximum එකේ ඉන්නවද නැද්ද කියලා අපිට මේ database එකේ මොකක්වත් කියලා rest කියලා නැති. It should have verge of at rest. ඒ කියන්නේ ලිස්සන්න ඕන්න මෙන්න condition එකේ ඉන්න ඕනේ. පැහැදිලි? Right. Correct answer is first one. Take number 36. Which of the following is the unit of momentum? Momentum පාට ලියන්න පුළුවනි mv minus mu equal ft. මෙතනින් ගත්තොත් ඔයාට උත්තරේ direct එනවා පුතා. මේ momentum change is the unit of momentum. Then momentum is force into time. No? Third answer is the correct one. එහෙම නැත්තම් මෙහෙම කරන්නත් පුළුවන්. kg ms minus 1 momentum මේක s minus 1 වලින් වැඩි කරලා s minus 1 වලින් බෙදන්න. Then upper one kg ms minus 2 becomes Newton. මෙයා උඩට ආපුවාම ns කියලා එනවා නේද බලන්න. Correct answer is third one. 38. The body of mass 2 kilogram is initially at rest on the frictionless surface, right? On the frictionless surface. පුතාලට මේ වගේ පුරුදු වෙන්න ඕනේ හැට දැන්. මොකක්ද? Area covered by the graph is equal to change of momentum. මෙයාගේ area එක ගන්න. ඔයාට එනවා මොකක්ද? 38. Area of the graph equals, it's a trapezium, no? Two parallel bases, 6 plus 4 divided by 2 multiplied by perpendicular height is 10. It could be 50. And that should be equal to mv minus mu, change of momentum. Right, change of momentum. According to the question, you have mass is 2, finally obtained velocity v, initially rest, it's 50. Then v becomes 25 ms minus 1. Then correct answer is second one. Okay, right. Number 39. When a bullet pulls a cart, when a bull pulls a cart, what is the force that caused the bull to move forward? සාමාන්‍යයෙන් අපි පොඩි ෆිගර් එකක් ඇඳලා ඕනනම් හිතුවක් කමන්නේ. නිකන් this kind of one. Bull's leg මේ විදියට ගත්තොත් මෙහෙම නිකන් roughly it pushes the surface back, no? It pushes the surface back. දැන් අර bull ඉස්සරහට යන්න නම් කාට් එක අදින්න නම් it should push the surface back. Then frontward it will have the resultant එහෙම නැත්නම් අපි කියනවා exerted force acting on the bull from the ground, no? ඒ කියන්නේ initially bull pushes the surface back. හරිද බලන්න. Initially bull pushes the surface back. Okay, right. Initially bull pushes the surface back. The result of that පුතේ මොකද්ද? Oh, surface will push the bull towards front. It's like friction. Okay, right. හොඳම උත්තරේ තෝරන්න බලන්න. අපිට දෙන්න පුළුවන් සාධාරණ උත්තරේ තමයි the force exerted on the bull by the ground, no? Correct answer is fourth one. ඒ කියන්නේ ඉස්සෙල්ලාම bull පොළව තෙරපනවා පිටිපස්සට. It pushes the surface back. Then the resultant one is the earth's surface will push the bull to move forward. නේද? අපි මොන හරි දෙයක් දැන් අපි පොළවේ ඇවිදිද්දී අපි ඉස්සෙල්ලාම කරන්න ඕනේ we should push the surface, right? අපි කරන්නේ surface එක push කරන එක by using the legs, right? Then pushes the surface back, then it will have the resultant one to move forward, right? From the frictional force. එක ගන්න පුළුවන් එහෙම නමුත් මේකේ friction කතාවක් නෙමෙයි කියන්නේ හතරවෙනි උත්තරේ අපිට හරි කියලා තෝරන්න පුළුවන්. Right. ගන්න බලන්න. Okay. The figure shows the semicircular uniform thin sheet. The center of gravity of the sheet is most likely to be found at. What මෙහෙම හිතන්න පුළුවන් නම් මේකට උත්තරේ ලේසියෙන් ගන්න පුළුවන් කොහොමද? පුතාලා මේක කොටුවක් විදියට මෙහෙම ෆිල් කරගත්තොත් බාන්න පොඩි අයිඩියා එකක් ගන්න පුළුවන් ද කියලා. Like this. If it is a block, right, like this kind of one, rectangular shape one, the center of gravity should be lied. Yes. Close to the midpoint. එන මේ හරිය වගේ තමයි මෙන්න මෙතන තමයි ඔය කියන විදියට center of gravity should be resulted at the midpoint if it is rectangular one, right? දැන් වැඩි තියෙන මෙන්න මේ කොටස් දෙක මේකෙන් අයින් වෙලානේ පුතා තියෙන the upper portion is removed no, then center of gravity should be lowered. එහෙනම් B ගොඩක් පල්ලෙහා වැඩි. එතනයි ප්‍රශ්නේ තියෙන්නේ. හරි නේද? දැන් පොඩි portion දෙකක් නේ අයින් වෙලා තියෙන්නේ. Then it should be better one is C, right? Okay. Then answer is third one. Okay. Right. Let's see the others. Number 41. Trolley X of mass M. Right. Let's take this one. A trolley of mass M, it's simple M of X, and the trolley of mass capital M are moving into same direction. This is capital M, this is Y. Same direction along the straight line on the smooth surface. The speed of trolley X is twice that of the trolley Y. 2V. This one is V, right? Okay. And when two trolleys collided, both move together as a common velocity. ඒ කියන්නේ දෙක combine වෙලා නේද පුතා ඔය කියන විදියට. ඒ කියන්නේ what you know M plus simple M. Done. ඒගොල්ලෝ ආයි කියනවා මොකද්ද? The velocity of Y is increased 20%. Y කියලා කියන්නේ මෙයානේ. तर මෙයාගේ දැන් velocity එක වෙන්න ඕනේ 20% වැඩි වුණාම 1.2v. හරි නේද බලන්න? ඇයි v plus 20% of v. v plus 20%, 20 by 100 into v. Could be 1.2v. That right. Okay. Then we can see the momentum conservation. M into 2v plus capital M into V equate M plus M into 1.2V. 2 simple MV plus capital MV M into 1.2 plus simple M into 1.2. Can we take this one into this side and this one into this side? දෙකෙන් 1.5ක් ගියාම 0.8 simple M we cancel. As all the points available, we cancel, right? Okay. Then equate this one into this side, 0.2 capital M. පුතේ දශම දෙකට දශම මෙතන 8 දෙවරක් 1යි දෙවරක් 4යි කියලා ඔයාලට cancel කරන්න පුළුවන්. ඒගොල්ලෝ ඉල්ලන්නේ වාගේ මොකද්ද බලන්න. Capital M over simple M, no? Right. Then answer is 4. Right. Take the final answer. Second one. Okay. Next, number 42. A ping pong ball is dropped from the height of 1 meter above a table. In every successive bounce, the ball loses its kinetic energy of some amounts. ඒ කියන්නේ පුතේ මේක වැඩිලා මුල් velocity එකෙන් reflect වෙන්න බෑ. After hitting on the ground, reflected velocity less than, yes, Puta, from the collided velocity, less than the collided velocity. එහෙමනම් ඔයාට මේක උත්තරයට තෝරන්න බෑනේ. මොකක්ද? We have to remove this answer. Reason, these two velocities equal. මේක ගැලපෙන්නේ නැහැ පුතා. After the collision, direction should be changed. එහෙනම් මේක කොහොමත් අයින් වෙන උත්තරවල. මේක ටිකක් හරි වගේ තියෙනවා. And these two lines should be parallel to each other. හරි නේද බලන්න. Okay, then What about next? Make it may velocities සමානයි මේකත් අපි අයින් කරමු. මේකත් ටිකක් හරි වගේ කන්ඩිෂන් එකක් තියෙනවා. අපි පොඩ්ඩක් චෙක් කරමු බලන්න මේකේ. හොඳම උත්තරේ මොකක්ද කියලා බලන්න. Okay. And here velocity and starting velocity, yes. එතන ඒ දෙක okay මෙතෙන්ට වඩා මෙතන velocity එක බලන්න වැදුනයින් පස්සේ මෙතන මෙයාගේ වඩා මෙතන velocity පොඩ්ඩක් වැඩි වෙලා තියෙනවා. ඒ නිසා අපිට the best choice should be this one, no? Third one is the best answer. ඒකෙදි අපි ආව පොඩ්ඩක් manage කරගත්තොත් එක එන්න ඕනේ මෙහෙමනේ. If this one is the graphical arrangement, first thing, this one is hitting one. ඊළඟට පුතා ඔහොමම reflect වෙලා යන්න ඕනේ මෙයා. ආපස්සට හැරෙන එක අපි මෙතනින් ගත්තොත් මෙන්න මෙහෙම. Right. Next statement is like this. මේකෙදී මෙන්න මෙහෙම point එකකුත් ඔයාගේ ඔළුවට එන්න ඕනේ. මොකක්ද? මේ velocity එකයි මේ velocity එකයි දෙක සමාන වෙන්නත් ඕනේ. මම දෙක එහෙම නේද දෙන්න ඕනේ කියලා. ඒ velocities දෙක equate වෙන්න ඕනේ. Yes. ඊළඟට reflected one take place like this. මෙතන අඩු වෙනවා. ඊට පස්සේ මෙන්න මෙතනින් ආපහු ඒක note down වෙන්න ඕනේ මෙහෙම. හරිනේ. මේ portion එකයි මේ portion එකයි සමාන වෙන්න ඕනේ. And gradually time taken should also be reduced. ඒ කියන්නේ පුතාලට මේ time එකට වඩා මේ time එක අඩු වෙන්න ඕනේ. මේ time එකයි මේකයි සමාන වෙන්න ඕනේ. මේ දෙක සමානයි ඒක හරියි. එනකොට මෙයාට වඩා මෙයාගේ time එක අඩු වෙන්න ඕනේ. Representing that one is nearly third answer. Then pick the third answer. Okay, number 42, third answer is the correct one. Okay, let's take the other one. 43. Average velocity of the object, no? Next one, you are asked to find average velocity. පුතාලට දීලා තියෙන graph එක බලන්න. It's velocity time graph. එන අපි ගමු equation of average velocity. Average velocity equal total distance or total displacement divided by total time, right? Then we are going to write average velocity equal total distance. පුතාලට මෙතනින් total distance එනවා 3 වරක් 3 9යි නේද? එක වැඩි කිරීම එක එකයි. මම හරියද කියන්නේ? 3 into 3 plus 1 into 1 divided by total time is just 4. It's 10 by 4, no? We have 2.5. 2.5 meters per second. Done. Answer is third one. Better one is third answer. Number 44. Right. Right. Number 44. The position of the particle of transverse wave traveling along x direction at a certain instance is given figure. The pair of particle with the same instantaneous velocity. Same instantaneous velocity should be considered with the direction. පුතා අල්ලන්න බලන්න. එකම gradient එක හිටින තැන් දෙකම. If you can identify. Answer is first one. වෙන තැනක් ගන්න බෑ. දැන් මෙතනදී ප්‍රශ්නේ තියෙන්නේ මෙහෙ. මේ බලන්න. ඊළඟට ඒගොල්ලෝ අපිට අපෙන් අහන විතර instantaneous velocity should be same. Here positive direct. This gradient is same as this gradient. මන්න හරිද කියලා කතා. ඊළඟට බලන්න A and D. It's wrong, right? A and D, they are having two different directions. B and C. B and C having different directions. C and F. C into this side, F into that side. Wrong. B and E. B and E, they are having different directions. පුතේ එකම direction තියෙනවා. මේකේ කවුද? B, F, same direction. ආයි තියෙනවා C, D, E having the same direction. Towards negative direction. Direction, not only magnitude, direction would be same. C, D, E having negative direction, B, F having positive direction. Okay, right. Then according to the question, given symbols, answer is first one. Okay. Number 45. Which one of the following dimensions equal to the spring constant? Spring constant මතක් කරලා ලියන්න ඕනේ. මොකක්ද? Question number 45. F equal kx, then k becomes force Newton divided by x, m t minus 2, right? Pressure, it's m l minus 1 t minus 2. Mass per unit length, m l minus 1, that's mt minus 2. Density, ml minus 2. පුතේ දන්නේ ඒවා ටික අයින් කරන්න. Force m l t minus 2. එහෙනම් ඉතුරු වෙන එක්කෙනාව මාක් කරන්න. Surface tension unknown one. Okay, but those two should be the same. Unknown වුණාට දන්න උත්තර ටික අයින් කරපුවාම ඉතුරු එක්කෙනා මාක් කරන්න. Okay, right. Number 46. Let's see. Equation is mentioned x equal at plus 0.6 bt square. පුතාලා මේක දැක්ක ගමන් මෙයාට equate කරන්න මේ ut plus half at square. t to t corresponding, at corresponding. එහෙනම් පුතාලා මෙයාව බලන්න. equate කරාද කියලා. ඒ කියන්නේ 0.6b equate half a. A becomes 1.2b. This could be the acceleration. They need the acceleration. It's 1.2b. Okay. Number 46, correct answer is third one. Let's see number 47. Consider the above following statements, right? First one. Elastic potential energy of a Haley spring of K under stretch of x is kx squared. Kx squared. Thus, the elastic potential energy is directly proportional to x squared. Statement එකක් විදියට ඒක වැරදි නේද බලන්න. හේතුව මෙතන එන්න ඕනි පුතේ half kx squared. එතන half එක දැමිලා නැහැ. And a statement is wrong, but elastic potential energy directly proportional to x squared is correct. Statement A is wrong. B. Work done by the gravitational effect on an object doesn't depend on the actual path of the object which is shifted. Thus, mgh gives the potential energy. If it is an inclined plane like this, the object moves from here to here. Potential energy is written mgh by subjecting this one is the vertical height. පුතාලගේ මේ vertical height එකත් එක්ක mgh base වෙනවා. ඒතර යන පාර මොක වුණා vertical height could be the substitution when you are going to find what? Potential energy. Then B statement is correct. A wrong. අහන්නේ හරි එකනේ. We have to check C. Next. Kinetic energy of an object remain constant with the time. Kinetic energy, kinetic energy remain constant. එහෙනම් මෙතන velocityමයි මෙතනක් තියෙන්නේ. එහෙනම් kinetic energy same. හැබැයි in a circular motion with a constant speed එකම speed එක ගත්තොත් ඒත් තියෙනවා kinetic energy same එකේ. In a straight line velocity and speed getting same, then kinetic energy will be same as it is constant velocity. Constant velocity, right? Then kinetic energy will be same. And here we have constant speed. Under constant speed, constant kinetic energy available. Then මොනවද පුතාලට කියන්නේ? With the time constant, momentum should also be kept constant. බෑනේ. මෙතන නම් හරි should කිව්වොත් පුතේ always. Should be constant means always to be maintained constant. එහෙනම් පුතාලා දැනගන්න circular motion, constant kinetic energy available as kinetic energy including both velocity and speed. But put in the circular motion, direction of velocity changes. Mean constant speed on a circular path, never constant velocity. පැහැදිලිද බලන්න? ඔව් ඒතර momentum කියන්නේ direction එකක් එක්කනේ. එතකොට circular path එකක යද්දි momentum එකේ මොකද්ද? Direction changes. Even though the magnitude same. පුතේ mv කියන එකෙන් මෙතන v වලට ලියන්න ඕනේ direction එකත් එක්ක. ඒ කියන්නේ when you write momentum right here, mv should have this direction. Here mv should have this direction. At here mv should have this direction. At here mv into same direction. Then constant momentum resulted, agreed. But here it doesn't have constant momentum as the momentum is a vector quantity. පුතාලට පේනවද බණ්ඩේ වැඩි? ඊටාම බරපතල සිද්ධියක් ඒක. එහෙනම් එතනදී ඔයා ජජ් කරගන්න ඔයාගේ මොකක්ද? Statement Z is wrong, A is wrong, B only correct one. Correct answer is third one. Mark කරගන්න බෑ. Right, number 48. A block of mass 1 kilogram moving with a speed of 4 ms minus 1 collide with another mass. Can we check? A block of mass 1 kilogram moves with 4 ms minus 1 collide with another mass of 2 kilogram which is at rest. Initial velocity 0. The lighter mass, this one, comes to rest after the collision, which means 1 kilogram finally comes to 0 velocity. And then the other one should travel now with a certain velocity. The loss of kinetic energy of the system. Why ඉස්සෙල්ලාම momentum conservation ලියනවා. ඊට කලින් ඕනනම් අපි හොයනවා මෙතන half into mass is 1 velocity 4 squared. Initial kinetic energy 4 වර්ගයේ 16 2යි joule 8යි පැත්තකින් තියාගන්න. Under the collision you are going to write m1 v1 equal m2 v2. m1 1 into 4 equal after the collision 2 into v. v becomes 2 ms minus 1. පුතාලා එයාගේ kinetic energy හොයනවා 2 kilogram 2 square දෙකට දෙක කැපෙනවා joule 4යිනේ. එහෙනම් finally 4 initial kinetic energy, final kinetic energy is 4 joule, initial 8 joule, and a loss of kinetic energy should be second one. හදාගන්න බලන්න. 4 joule. Okay. Can we check last two? Right. Number 49 and 50. Right. Number 49. A passenger inside the train traveling with the velocity 3. This one is the train. It goes like this. Okay. With a velocity of 3 ms minus 1, throws a coin upward, vertically upward, right? Throws the coin vertically upward by 10 ms minus 1. By 10 ms minus 1, right? But even though the object is projected up, right? This one already available, this velocity from the moving railway cabin, right? Then this is automatically made this kind of projectile motion, right? You are given 3 statements. When it is assumed the coin does not roof of the train, train එකේ වහලේ වදින්නේ නැහැ කියලා, it does not roof in the rain. The correct statement of the following is, first one, if the train travels with a uniform velocity after the coin is thrown, it falls on the hand of the person again. Yes. Why? The train travel from here to here by a certain distance. පුතාලට ඕන නම් හොයන්න පුළුවන්. By applying S equal ut plus half AD squared, we can find the time of flight S is 0, u10, time is t, plus half acceleration minus 10 t squared. Then 5t squared equal 10t. T becomes, is it like 2 seconds, right? Okay, then horizontal range of the coin is S equal ut 3 into 2. It could be 6 meters. After traveling the train by 6 meters and traveling the coin by 6 meters, then it can be taken by the thrower after traveling 6 meters and after shifting 2 seconds time duration. Then A correct. B, if the train travels with uniform velocity after the coin is thrown, the time of flight of the coin before fallen on the hand of the person is 2 seconds. Perfect. C, if the coin travels with the uniform velocity after the coin is thrown, the train has traveled 8 meters. Wrong, right? It could be 6 meters. Then wrong answer, C. Wrong. A and B correct. And D, although the train accelerated after the coin is thrown, the coin falls on the hand where train එක accelerate කරොත් පුතේ train එක person උත් එක්ක ටිකක් ඉස්සරහට යනවානේ. ඒතර coin එක මගට වැටෙනවා. ඒතර මිනිස්සයා ඉන්නේ මෙහා. නේ? After the coin is thrown up, if the train is accelerated, the point at which the coin hitting on the body of the train behind from the position of the thrower, right? Now, then correct answer is A and B correct. Yes, correct one. Then A and B is the correct answer. Okay, right. Question number 50. Two identical blocks A and B connected by a light spring, like this. Light spring are suspended by the string attached to the civilian as shown in the figure. Initially, the system is at rest and suddenly the string breaks. Okay. Suddenly the string breaks. Immediately after the spring is broken, what will be the downward acceleration of the upper block of A? දැන් මේක rest එකේනේ පුතේ. The forces mark karot mana denne ba. This one is having the weight mg. This is also having the weight mg, no? That's the thing. Okay, then two identical blocks A and B, mg available, connected by a light spring, are suspended by the spring attached to the civilian as shown in the figure. Immediately system is at rest and suddenly the string breaks. එයාලා කියන විදියට string එක තමයි break කරලා තියෙන්නේ. මෙන්න මේක කපලා දැම්මෝ තින්නේද? එයාලා අහනවා මොකද්ද? What will be the downward acceleration of the upper block? මෙන්න මේ upper block එක විතරක් අපි පොඩ්ඩක් ගත්තොත් බලන්න මෙහෙම දෙන්නේ කියලා. Okay. It consists with mg right. පුතේ දැන් ඔය යටි එක්කෙනා rest එකේනේ තියෙන්නේ. එතකොට මෙතනින් එනවා tension එකක් මෙතනත් එනවා මොකද්ද spring එකට additional tension එකක් බලන්න. It is equal to the weight of the lower mass. මෙන්න මෙයාට ඒක සමානයිනේ. ඒක තේරුණාද බලන්න. එහෙනම් as soon as the string is broken, the upper mass of m a, this one upper mass, will be experienced towards downward 2mg force. බලන්න සම්දි අර මේ string එක කපපු ගමන් අර දීලා තියෙන double force එක. ඒ කියන්නේ මෙයාගෙන් එන weight එකයි අර උඩින් A ගේ තියෙන weight එකයි on weight and additional to that the spring making downward force, right, equal to the lower mass. මෙන්න මෙයාට සමාන force එකක් එනවනේ පල්ලෙහාට. That is also created downward. Then 2mg is the downward weight. පැහැදිලි කතන්දරේ? The 2mg is the force, but we are applying F equal ma only for කාටද මම මේක දාන්නේ 8. එතකොට එනවා පුතේ ma. එහෙනම් a becomes 2g. හැබැයි මේක එක මොහොතයි තියෙන්නේ. As soon as this is act, it will be vanished. ඊට පස්සේ acceleration එක convert වෙනවා g වලට. Gravitational acceleration. එහෙනම් පුතාලගේ උත්තරේ වෙන්න ඕනේ 2g. 2g is fifth answer. Right. හරි. ඔය තියන්නේ ඔයාලගේ second term එකේ term test එකේ total discussion එක පුතේ after next week. Yes, after next week we will discuss about structured essay paper. හරිනේ. මේකේ අඩුපාඩු ටික හදාගෙන booklet එකක් විදිහට හදලා තියාගෙන දැන් ඊළඟට ඔයගලගේ ඉස්කෝලේ එන පළවෙනි term test එක හොඳ මට්ටමින් කරන්න. නේද? මේකත් උදව්වක් කරගන්න. Right. Okay. Goodbye.